Okay, so far so good. Okay, let's move on to our last example. So let's try one that involves simultaneous equation. Okay, let's solve for simultaneous equation that involve exponential equation. How to do? Don't worry, let me give you an example. Okay, so over here, let's solve the simultaneous equations. There's equation 1 here, equation 2. How do we solve them? How do we find the value of x and y that can satisfy both equations simultaneously, concurrently? How do we do that? Okay, so let's try. Not difficult, let's try. So from the first equation, 9 to the power x over 27 to the power y equals to 1. Okay, you notice this is a base 9, this is a base 27. What base comes to your mind when you see a 9, you see a 27? You think of base 3, right? Base 3, right? So over here, instead of writing 9, you can write 3 to the power of 2x. Yes, because 9 can be written as 3 square, right? Then 27 can be written as 3 cube. Right? Because you recognize that 3 cube is 27. So once we write it in this way, we realize that, hey, let's recall a law of indices. When you divide two expressions with the same base, what do? We subtract the power. So this is 3 to the power of 2x minus 3y, right? 3 to the power of 2x minus 3y equals to 1. But the number 1 can also be expressed as 3 to the power of 0. Mister, why do I want to do that? Why do I want to make this as 3 to the power of 0? Remember I talked about 2 terms exponential equation? Right? We try to make the base the same and then we equate the power. So we make the base the same. So 1 can be written as 3 to the power of 0. So from here, make the base the same, equate the power. So 2x minus 3y is equals to 0. Equation 1. You form your first equation already. Okay, not difficult, right? I'll use blue ink for the second one over here. So we have 4 to the power of x times 2 to the power of minus 2y equals to 4. So I see a base 2, I see a base 4. What can I do? I can convert everything to base 2, right? So instead of 4, I can write 2 to the power of 2x, right? Because 4 is actually 2 squared, right? Bracket means multiply. Then minus 2y. The number 4 can be written as also base 2, so 2 squared. So over here, let's recall a law of indices again. When we multiply two expressions with the same base, what do you do with the power? Add up the power, right? So 2 to the power of 2x plus negative 2y, still become minus 2y equals to 2 to the power of 2. Okay, mister, what are you doing over here? Same thing, make the base the same, equate the power. So over here, equate the power. This tells me that 2x minus 2y is equals to 2. You can form a second equation here, but I would prefer to do this. Divide throughout by 2, so I get something that's more simplified. Okay? But if you say, no, mister, I want to continue from here, also can. Doesn't matter. You can also solve from here. Actually, it might be better to stop here rather than divide throughout by 2. Reason is because Mr. Ng realized, hey, there's a 2x here, there's a 2x here. Can you see? So from here, right, maybe, okay, so I'll stop here. So now what we do is we solve this pair of simultaneous equation, right? So 2x. So what I can do is if I were to subtract both equations, I use the red ink now. I take equation 1 minus equation 2. Okay? So what I have is 2x minus 3y. Okay, this 2x minus 3y, equation 1 minus 2x minus 2y equals to right hand side minus right hand side 0 minus 2. So 0 minus 2 minus, I have a negative 2 here. So over here I know that I expand this 2x minus 3y minus 2x plus 2y equals to negative 2. So my 2x and my 2x will cancel out itself. Right? 2x minus 2x is 0, disappears. So negative 3y plus 2y is negative y equals to negative 2. That tells me that y is equals to 2. See? Solve for y already. Now can I solve for x? Of course I can, right? Easily I can solve for x. So over here I can use equation 1. So 2x minus 3 times y is 2, is equals to 0. So 2x is equals to 6, x is equals to 3. So I solve for x equals to 3, y equals to 2 is a solution to this pair of simultaneous equation. In exam again, how do you double check? Sub x equals to 3, y equals to 2 into the left hand side of the equation. Okay, you will definitely get 1. Definitely will get 1 if you're correct. Then after take x equals to 3, y equals to 2, substitute into the left hand side of the second equation. if you're correct, you will surely get the value of 4. Okay, so if you get 1, if you get 4, when you start x equals to 3 and y equals to 2 into both equations, you know you're surely correct. Okay?